Hi everybody, my name is Matias Huhta. I'm here to talk about writing a language server. It's gonna be quite a technical talk. It's gonna have way less jokes than my usual talks have, but bear with me, it has some memes, maybe if I remember to put them in. It's been a hectic month. But yeah, a little bit about me. My name is Matias. I go by the alias Matsu all around the internet, on Twitters, on Mastodons nowadays, and on Discords. I don't really use anything else, and I don't really use those either. I'm a open source enthusiast. I run a small software company here in Turku. I'm a developer tooling developer, so I develop the tools that developers like to use. It's kind of an inception. And I am an avid web component supporter, even though that's not this day's talk. That is kind of the reason I ended up approaching this subject. So, some history on code editors and code and text editing in general. Is there anybody in the house currently who has started programming with these? One person. Can we have a round of applause for our hero? How about then people who started with text editors, so no IDEs, only text editors? A couple of people, yes? Then, well, IDEs are coming in later, and I can just deduce that the rest of you have started there or have not started at all. But let's look a little bit about text and code editors in general. The history of those started around the 60s. Before that, we all had punch cards and a cumbersome workflow, and, well, stuff did get done, but stuff didn't get done fast. Well, then we had some really nice technological improvements in the 60s. We have line editors. Has anybody here used a line editor before? So not a text editor, but a line editor. A show of hands? A couple of people. And that is because they are quite cumbersome to use. I wouldn't use them myself, because instead of nowadays you have your 4K screens, you have your ultra-wide screens that show like 2 million characters at a time, because you zoom out so far that you can see all of your project in one screen. Well, line editors could edit one line at a time. We had one line and one line only. It was cumbersome, it was hard, but it had to be done. There was editors like this which worked with printers, so you didn't have a screen. You had a machine that printed out the source code of that row that you were accessing. So if you didn't remember how your code worked, your boss might have gotten quite angry of you because you were spending so much paper. Examples of these editors are ED and QED. They really were great with the namings back then. Then we had code editors, the greatest of them all. We had Emacs, we had Lex, we had Vim, and you shouldn't know about any other editors. Those are the real ones, the real OGs. We had those rolling in through the 70s, 80s, and 90s, and then even till today, we have text editors coming out. And if we look at the features that these text editors were supporting during the time, were, of course, we could edit text. It wouldn't be a text editor if it couldn't edit text. Some of the newer ones had syntax coloring, we had brace matching, we had line numbers. We were spoiled, we had line numbers. Those are not a given nowadays. We could select code around our project, but what was missing from our nowadays workflows with our IntelliJs and VS Codes was advanced language features. We didn't have any go-to definitions, we didn't have any code completions. You had to actually learn the language, not use completions all the time, or copilots. We didn't have any smart completion or intelligence, as people say it nowadays. Again, if you saw my last week's talk, I was blaming a lot of naming on Microsoft. Intelligence, one of those namings. It's Microsoft term, nobody else uses it, but everybody around the internet uses it for some reason. It's like Google renaming everything. Well, then we get to the actual editors, like who started their development career with IDEs? So who actually downloaded a full-blown IDE as their first text editor? A couple of hands. You were spoiled, but it's a great way to approach developing code. Like if I had to learn code development nowadays, I would start with IDEs because they just do so much work. But what was the history of IDEs? We had like stuff like Turbo Pascal. So if you had to like write Pascal code, there was a IDE that shipped like with development environments. We had Visual Basic editors, which could like edit the greatest programming language in the world, Visual Basic. And then we had, well, some of the modern editors. We had PyCharm, so pretty much everything from JetBrains. We get all of these great features in those editors. We have Android Studio, the same people who made the other editors, but for mobile development. And as we can see, the the history of these environments has really gone far by having just a window of text and some tools on the side, to having some more panels on the side, and some more panels on the side, and some more panels on the side. And we have like more panels and less code by the year and by the decade. And if we look at the feature list of IDEs, we can say that, yeah, these are really needed against text editors because these provide advanced language features. These provide language technology, language or technology-specific tools. For example, we had a Android Studio. It's a development environment for Android. You want to have a development environment that's focused on developing something for your platform. We had smart code completion, even smarter than nowadays text editors have. We had refactoring, we had code generation tools, we had everything. Pretty much like 50% of the code I write nowadays is not written by me, it's written by the editor itself. And that's great. Like, I don't want to write that boilerplate. But what has come with the IDE support is usually a double-edged sword. So while we have something that does language and technology specific things, we are kind of throwing multi-language support out of the window. Yeah, you can have IntelliJ configured so that you can use Java and JavaScript and everything in it, but at the same time, the editors are usually focused on one subset of languages. You cannot write C with, for example, Android Studio. I mean, you can with plugins, but then we can get to the next slides, the new wave of, or the new age of editors. In the new age of editors, we have things like Visual Studio Code. Who here started coding with this editor? Nobody started with Visual Studio Code. That's new, because this is what they teach nowadays in schools, I think. At least everybody used it when I was visiting there. Then we have something like Fleet. Has anybody here ever heard of Fleet? Yes, the JetBrains people, because this is pretty much a Visual Studio Code killer by the makers of IntelliJ and, well, JetBrains in general. But when we look at these editors, we can know that they are all powered by a same kind of a power. And that power is plugins. So there's a paradigm shift here. We have moved from having a ready-to-ship boxed development environment and moved into a small text editor that can be then enhanced with plugins. You don't have to have an editor for all of your languages in your project. You don't have to change to C Lion when you want to write C code and IntelliJ when you want to write Java. You can just have Visual Studio Code on your computer. You can download the Java plugin and the C plugin, and you're good to go, kind of. But how are these actually related to our main topic, which is language servers? Well, we will take a look at what language servers do and what LSPs are and what all of these cool acronyms mean. And while we are doing it, we will kind of know what actually powers these plugins in for editors like Visual Studio Code or Fleet. And the first thing is we will go into what is an LSP. An LSP stands for Language Server Protocol. Try to say that 3 times fast at the after beers. It's hard. And it's kind of a technology that is used to communicate between the language services, so the actual powerhouse that's powering all of your smart IDE-like features, and the client, which is your code/text editor. The editor could be, it could be like a fork of Notepad if you wanted it to, but you don't want to do that. It could be an online editor like CodeMirror. It could be Visual Studio Code. It could be even IntelliJ. IntelliJ has plugins to communicate with language servers. And what are the features that usually are shipped with language servers are the features we were talking about missing in code editors. So auto-completion, go to definition, find all references, and all of that. And I'm sure that pretty much anybody here who uses Visual Studio Code in your workflow, you are using LSPs under the surface, even if you didn't know it, because when you're writing TypeScript or JavaScript, it's using TS server, which is TypeScript server, which is TypeScript language server under the surface, and you're getting all of your sweet completions and code actions from there. So how does the communication actually work? It's using a technology called RPC, JSON RPC to be exact, and it communicates between a development tool, so our code editor, and the language server itself. And if we take a look at the communication graph here, this is just a basic example of a user opening their code editor. Well, first we have the first line from the top. We have the user opening their text editor. It's a did open request sent to the language server. And since it's RPC, we don't have to do this. I send you a message, please send one back. I send you a message, please send one back. We can do asynchronous messaging. We can send them like 10 requests and get anything back when we want it, when we need it, when it's processed. It's a large project. We can send 100 requests then because it's slow. But yeah, we open the file. On the next file, we see a did change event. Well, anybody here with any knowing of how text editors work knows that did change. Well, the text document changed. We tell the text editor, that language server, that something changed. And why do we have to do this? Because like we have the client here. We changed the code and it shows on our client that it's changed. But as we spoke, the language server is a separate entity. We have to tell the separate entity also that something changed. Because like if you had a server in China and you had a client in Finland, like, yeah, you can type something into the input box on a HTML page, and you can't expect the server in China to know that. Well, you can kind of expect the server in China to know that you wrote something into the input box, but that's not how the application is working. That's stuff around the application. But having the actual server knowing what you did, you need to send a request of that change. And the same applies here because they are two separate entities. Then we have one request going the other way, which is publish diagnostics. So, okay, we have our code file open. We have some edits in there. There's a error on line 3, and the LSP knows it. The language server knows it, and it wants to notify the client, the user, that there's an error. They publish diagnostics. So they just send an array of diagnostic objects back to the user. The client can then parse it, show it on the right node, and be like, yeah, you are using double equals instead of triple equals, like in JavaScript. You can show any diagnostics on the file. Then we can have the user doing other actions. We can have, for example, asking for definition, going into a file, for like a different file, the server responding with a location of that file, and then the client going to that file, and then the client actually like closing the previous file behind them. So this is just the basics of how the communication works. It's asynchronous, it's RPC, it's really fast, it's not over the internet, it's through the wire on the same computer. Like, I mean, you could do language servers over the internet, but I don't think even 5G is enough for a good development experience for that. But then we can look at the requests that are sent there. The requests are quite simple, so if you know any JSON, you can see that the requests aren't really all that hard to like discern. They're just JSON requests. You could use some binary if you want to be really fast, but JSON is pretty much the format that people have gotten used to because, well, JavaScript. And the JSON format, well, these JSON requests go through the RPC and are handled by server, and the server responds with a equal JSON response having some information. For example, here we had our definition request, and then we are sent with the location of the actual definition of the file. Well, that's like a quick overview of like what an LSP is in general, but like, what is it for? This is really technical, and we are just bouncing messages, and it's really boring. Like, why do we need this kind of messaging? We already have text editors. Well, the text editors don't have these features out of the box. This is something that the LSPs are providing them, even if you didn't know it. So some of the features that these LSPs, for example, I will use TS server here as an example because I'm pretty sure this is too close Frontend. Everybody here has worked with JavaScript, so they know about TypeScript and they know about completions in JavaScript. So, for example, TS server has these capabilities and a lot more. They can have like code completion, so when you're writing your class names, you don't have to write the whole class name. You don't have to write any of the standard APIs if you are providing them with information that you're using the standard APIs. You can have hover actions, so every time you hover your mouse above a symbol, it will tell what that symbol is. Maybe it's types if you're using typed languages. Then you have go to definition. You can go to definitions in your code, go to references, so go backwards, so you can go to your class and go to references, so you can see everywhere this class is used. This lamp is really making me hot. It's okay. And then there's diagnostics, like we discussed. So all of these features are provided by the language servers itself. There's additional features, for example, code formatting, refactoring tools, but those are not mandatory. These are pretty much like the only mandatory ones for you to fulfill the spec. And then you're like, but why do we need LSP? VS Code plugins already have these features. Well, that's the thing. They're VS Code plugins. Not everybody uses VS Code. You are, for example, you're working on a new file format. You're making a foo.tlf, Turku Frontend file format. It's like a mixture between YAML and JSON because that's like the greatest data format ever. If you want to ship editor support for that, do you really want to be writing plugins for all of the editors? You can be like, yeah, just use VS Code, but not everybody is going to use VS Code. So how are we going to get adoption for these? Well, we want to have like a standardized way of communicating these. And we can see the example here. We have just as we discussed, we have multiple languages and we have multiple editors. They kind of build our matrix. We have Go support. How do we support it in Emacs, VS Code, and everything? Well, with LSPs, we can just write a language server once and use it everywhere. It's like Java. It's great. And a more visual format of that is, well, we can see that there's a lot less lines, even on 3 editors and 3 code languages, when we are using something centralized like LSPs. And there would be even more if we had more languages, because no tech house runs on only 3 languages. So we want to really be reducing the rewriting of tools, rewriting of code help tools. So we don't want to be writing all of these plugins multiple times. We want to be writing them once and getting on with it. Then if you want the support for example, Vim, for this server, you just have to plug it in with your LSP client. And that's a lot less work than having to write the whole code completion features onto your client. Like, until today, until like a few years ago, this was the norm. We had like Vim plugins for HTML parsing or HTML language features or JavaScript language features, but nowadays we are just able to use LSP and we can just plug into the same language servers that VS Code plugs into. So let's get into the actual meat of things. So how does it work? Well, we looked at the communication before. So it works by communicating between the language server and the client. We looked through the requests, but that's only the communication, like how are the files actually analyzed. Then we get to our second acronym of the day, called ASTs. But before that, we are going to look at like some of the problems that ASTs are fixing here. So say we have a JavaScript file. It's a web component file because, yay, web components. We have a full file of JavaScript. We have different kinds of scope here. Like scope in JavaScript is kind of finicky. We can have scope, we can kind of not have scope. We are using classes, so we have clear scope. We are writing something into my function inside of our class. How do we know what kind of definitions or code completion actions do we want to provide the user? We're writing doc. Of course, we can just like provide with the regular window object document and everything like we do that. But what about the rest of the file? We have imports there. How do we know what kind of things starting with doc we have in those imports? How do we know what kind of a scope we have around the function? How do we know we don't want to pass something that was defined in the render function into the my function? How do we know all about all of these scopes? Well, I mean, you could start parsing it. You could start wondering like where the context is actually going. You could hate JavaScript for a while. And you could wonder like, okay, that was, even if we were able to build it for JavaScript, we were able to build a context-aware completion support for JavaScript, then we have HTML in our web page. How do we make it context-aware here? I mean, this is just text. We can use regex, but as everybody else knows, regex and parsing HTML kind of don't go together. So unless you are really the 10x developer you don't want to approach that. And that's where we enter into the field of ASTs. So ASTs are, the formatting there is not nice. ASTs are an acronym for abstract syntax trees. Like, it really makes you sound smart when you're talking about abstract syntax trees. Like, nobody uses trees anymore when you're doing web development, and now you're using abstract trees. Like, what the hell are those? Well, abstract syntax trees are a structure of your text document, usually something in source code, written in a formal language. And each node in your tree structure here, in your abstract syntax tree, denotes a construct occurring in the text. Let's see it kind of in action. For example, here we have the technical, straight out of Wikipedia, nobody understands example of how abstract syntax trees work, or even trees work. It's a tree sign where we have like, while something is less than something, we might do something, and what we do inside of that tree structure, we assign a variable and we plus a variable, and you cannot turn this into source code. Or you can, but it's like gonna take a lot of time and a lot of patience and a lot of nerves. Well, if we had our good old JavaScript file here, and we wanted to, for example, examine this import statement using abstract syntax trees, ASTs. Well, the AST of that symbol would look like something like this. Keep in mind, every single line here, from the source file to end of file token, is a JSON object. Well, it doesn't have to be JSON, it can be anything really. But it's an object that contains data. And if we are looking at this, we are like, that's one line of JavaScript, and that's a hell of a lot of abstract syntax trees to parse through. And that's just one line. We had like a full JavaScript file here. How does that look? Well, we can deduce here that abstract syntax trees really are an abstract representation of our code structure. And it really starts to make sense when you are looking at it like in action itself. For example, let's split the code example onto multiple lines, just for clearer examination, and also because the code highlighting tool didn't work for partial lines. If you want to look at the import statement here, I mean, anybody reading that abstract syntax tree knows where the import is in there. It's there. It's the import declaration. It has information about it. It has like a kind, so you can have it in a switch statement. You don't have to else if through everything. And then when we take a look at the tree itself, we have everything inside that. So the import declaration itself also contains all of the information about the import declaration, because that's how effective tree structures work. We are able to just find an import declaration, and then we can just parse through its children, proper English, and see all of the information there. And if we want to look, for example, the identifier, so we want to know what kind of class names or functions we are importing from our statement, well, we have a series of import specifiers here. So it's a really curable and a really clear tree structure when you start proceeding through it. For example, we want to know the path where we import something from. Well, that's easy. We can just find our import declaration and find the string literal at the end of the import declaration. It's the only string literal in the import declaration if it's proper JavaScript. So it really eases us into querying these. Like, if you are using regex to query these, trust me, I tried. You're not going to have a good time. When you're using some tree structure like this, you are able to find all of these quite easily. And when you're looking at the objects themselves, this is just the string literal we were looking at before. It has quite a lot of information about the element itself. It has the text that it's on. Actually, we had some highlighting, yes. It has the text, which was the import statement itself. We have the starting position. We have the width of the statement. So it's 6 characters. It's the tick, lit, tick, and the colon, I think. And then there's the kind. So we know kind is kind of like what kind of a token is it in our JavaScript? It's a string literal. It's just a string, nothing special. And then we have just a real positional description of our token. So this gives us a really good programmatic approach into approaching our code editors and approaching what kind of code we have inside of those. And if we are wondering, how, the first step is yeah, I learned about ASTs. I want to know, I want to use these, but how can I generate these? Well, there are tools. There's tools like TreeSitter. We have TreeSitter, which is it's built for tree views. It's built for building trees. It's a TreeSitter. And the difference here is it builds concrete syntax trees. It's kind of a different thing from abstract syntax trees. It's actual syntax trees, but this would be a 2-hour talk if we went to concrete syntax trees. So concrete syntax trees in general are able to be transformed into abstract syntax trees and handled there. Then there's tools like Acorn. We have Acorn, which parses JavaScript. You can get an AST out of that. And there's a tool in pretty much any parser or compiler you know. So there's a lot of things that we didn't go through, which are really easier to show by demoing. And we have a AST viewer here. We have just a regular old JavaScript file, and we have nothing in it. But still, we see in our AST something in here. Well, let's see, we wanted to create a constant. This is really hard with one hand, but bear with me. And we have another constant in our file. I'll also zoom in a little bit so everybody can see. And we wanted to, for example, it was supposed to be bar, not bay, but whatever. And we want to, for example, find every single variable we are declaring in our file. For example, we want to see that no programmer is using curse words in their variables. There's no X, there's no bollocks, there's no bad words in your source code to denote your variables. For example, the project I'm in, this really could be a helpful linting tool to have variable name checking. We could do a query on this abstract tree. We could find all of the variable statements, look into the variable declaration and the identifier itself, and we can get the text inside of it really easily. We can use query languages to do the querying here. We don't have it for this tool, but we might have it for other tools. And it really makes it easier to parse through these abstract syntax trees. And for example, if we wanted to make a small linter for, this is TypeScript, it uses the TypeScript linter. We could, for example, make a linter that checks that we are not using double equals everywhere, the thing we were discussing earlier. We can do this. Well, it's already screaming at us, well, for some other reason. But we can really easily make sure that none of our code uses double equals by turning it into an AST. Well, we could regex this, but then the regex would not be able to catch this. It would not be able to catch, well, all sorts of things the minimizers do to JavaScript. I don't even want to go into those. We could query the whole code base of ASTs by going through the whole tree, and as you might see, equals equals token. We could just find all of these tokens, and if there's one in the project, we can just throw an error at it. It's a really powerful tool, and I'm not going really into all that deep into how much this could save in your linting and workflows and editing your code. But at the same time, we are looking at this code, and we are going back to the slides. And we can look at another AST Explorer, which is light-themed, bear with me. And we can see that there's a lot of, it's not just JavaScript. We have been talking about JavaScript, TypeScript all day here, but it's not just JavaScript. We can do it on pretty much any real programming language. There's more, but they're just not on the site. There's different kinds of parsers for these. And since we have a functioning syntax tree, when we have language put up like this, and we have the syntax tree, even if we changed our language, well, the code examples change, but the syntax tree and how it works doesn't. We still have our import declarations. We have our, let's see, we have our identifiers somewhere in the tree, somewhere. And we have all of the abstract stuff about our syntax tree, even if we change languages. So if you, for example, are building a transpiler, you want to change JavaScript into Java, you might be approaching it by building an abstract syntax tree out of it, and then just like throwing it at another parser that can handle abstract syntax trees. There's tools that are using AST manipulators that you most likely are using. Well, we talked about this a couple of years ago, so even if these ASTs are looking a little bit weird, so you are not understanding what they actually do, at some point you just like start to see it like the matrix. So you're like, yeah, that's an import statement, that's a red head, that's a matrix reference, and that's all about it. Dry jokes. So in summary, we can look at this, that the ASTs really allow us to make more precise and context-aware operations to be executed on source code. And if you want to read about those more, you can go to Twilio's blog about it. And getting it back into the fact that there's a lot of tools that are using ASTs already. How many here has used Istanbul.js? How many here doesn't know that they are using Istanbul.js? How many of you has run a test suite with coverage on JavaScript? Oh Lord, not too many. You should run tests and you should run them with coverage on. But you might be wondering, like, how does it know where to highlight it? Like, how does the test suite know where does the code actually go? Where does the code visit and where does it not visit? Coverage is that. It shows where the tests are covering and where they're not. Well, Istanbul.js, for example, uses ASTs. It takes the whole JavaScript file, it injects its own JavaScript inside there by using the AST, because if you did that by regex, you most likely would just break the code base at that point. It injects its own functions inside of the code that increments stuff inside of the system, and it just gives you information on coverage. Then there's stuff like ESLint. Who here uses ESLint? A lot of you. Who here has written a rule for ESLint, like your own ESLint rules? Not too many. Some. Well, those keywords like class declaration, identifier, import statement, all of those might be looking a little bit near to you if you have written ESLint rules, because they are using abstract syntax trees, and you can use abstract syntax tree selectors to select elements on your ESLint profiles. So if you read through ESLint docs, you will see a lot of stuff relating to what we have talked about today. But yeah, let's try to wrap this up. How can you actually start like using language servers and contributing through those? Well, static analysis is an incredible, powerful tool, and ASTs and LSPs and acronyms are really I think it's the best approach to approach these things in code. You can do static analysis on pretty much any language, on any kind of a source code. It doesn't matter if it's minified, if it's not minified. It doesn't matter if the syntax is formatted or not. It doesn't care about all of those things. All of your like normal text editor things care about that syntax stuff, but ASTs don't care about that, and it really makes it a powerful tool for static analysis. For example, linters, for example, test coverage tools, for example, there's pretty much anything. I'm working on a tool that's parsing through minified source code to find where you are doing your fetch requests to. Don't ask why. It's kind of a hobby project, but it's kind of like it makes you think about what you put in your front-end source code. Then there's stuff like, well, possibilities are endless. You can expand the language server capabilities. So if you learn to use the technology, you can of course be like, yeah, we have the AST already. Why can't we have like extract this block of code into its own function? Why cannot we have that on our language server already? You can expand it. You can just build that into it. Like what TreeSeeder has done like querying ASTs really easy. So you can really just like be like, okay, we went through this code, go up the tree until the function we're out of the function scope, put a new function there, put this there, everything works. No text parsing had to be done, just tree parsing. You can create language servers for your proprietary languages or file formats. For example, I don't think YAML has a language server yet. They're building one at Mozilla. I was talking with Emily about that. And they are building one, but like there are a lot of file formats that don't have language features yet. And you could pretty much write language features for anything. It could be Pokemon card deck list generator outputs. You could just like write a completion engine for your Pokemon card collection that just gives you all of the information about those when it knows how to read the file format. It's like the world is your oyster at that point. You can create all of these language analysis tools and code quality tools. Like if you have not written an ESLint rule yet and you're hating your ESLint config, really please take a look at those because they are really a high-level approach into ASTs if you are interested in those. Well, you could build code generators. So when we have our TLF file, we have our custom file, or even if you have an idea of like, okay, I want to make my own custom format to write my HTML in React, in JSON, in CSS generator, we can create those. We can create any kind of bundlers using these. Like if you're approaching these problems doing like regular text parsing, like regex or something, please stop. I tried. It's not going to work. Use LSPs, use ASTs. And yeah, if you want to get started with language servers, there's a languageserver.org, which is a open source organization for learning about language servers. I really like having 30 minutes to talk about this subject is really like just trying to get people into the know of things, and it doesn't cover all, but if you want to learn more, there's some information there. And also there's information in the Microsoft language server protocol repo, because the language server idea itself, it was invented at Microsoft, or developed at Microsoft. Maybe not invented, but developed there. So they are kind of the forerunners in there. And also in the Visual Studio Code documentation, there's extension guides for how you could extend your language servers. For example, you could write, there's a plugin that supports CSS rules in styled components. That's a language server. In a sense, it's a language server plugin. There's stuff that like gives you template literals that support HTML completion. That's a language server. Pretty much everything you're using to get those super special features is a language server at this point. And, sorry. And if you're interested in ASTs, the TS-AST viewer, the thing we used earlier, the other AST viewer, just Google AST viewer pretty much. You should play around with those and get interested in like how those work and how they can do something. And well, this is a JavaScript meetup, kinda, sorta, front end, whatever. So TypeScript documentation. Has anybody here actually like read the TypeScript documentation at all? Like the compiler documentation. It's interesting. Go check it out. There's like a whole wiki on the compiler API. It's really cool. It's not well documented, but it's an adventure. If you want to contact me after this, you can contact me in stuff shown on the page. But yeah, that's all me. Thank you very much. Do we have time for questions? We had one question there.
Yeah, so a major use case for the language server is that you can build different plugins for different IDEs, or I mean that you can reuse the same kind of core logic. But is there any kind of another architecture that would be somewhat popular, or are they in practice all some sorts of client-server, local client-server implementations?
There are some file formats. For example, there's the web types that IntelliJ is supporting, and some other editors have been adopting that. But those, most of them are usually proprietary file formats or documentation formats. Like there's a JSON file that documents something, and then the editors are just well, the crowd has forced them to support that file format, and then the support comes there. But there's not, as far as I know, there's not any other real larger initiatives on any kind of a client-server architecture approach into adding these plugin supports to editors nowadays.
You mentioned binary format. So
yeah.
Why would you use that for local communication?
Communication with binary can be a lot faster than JSON because it might take a lot less data to communicate the same thing, but it's you might have to work on a proprietary format and everything. The only reason you would use something like a binary format or a library like binary JSON to communicate faster is just sheer speed. But you're working on your local machine, so you shouldn't be worrying about speed at that point. If your own memory and CPU is the bottleneck, then you should really be buying a new computer at that point. But yeah, it was a throwaway comment, but it was good that you asked about it because you shouldn't do it, but you could. And in JavaScript world, that doesn't always go like that. It's you can, but should you? But yeah. Any other questions? Yes.
A technical detail I don't think you mentioned, so also relating to speed. What's the underlying transport for LSP?
The JSON RPC is the communication protocol for it, and the actual transport mechanism that supports that is, well, it's not in the spec, so you can write pretty much anything for the actual implementation of it. It's just JSON via RPC. There's no real specification on what the actual implementation of it is in general.
I don't know, but does Eclipse fit into this story? So
we had a discussion at work that Eclipse even has a plugin for Vim bindings. So Eclipse is a usable editor nowadays, and I'm pretty sure there was it might be in a plugin format, but I think Eclipse and all of these old school editors support LSP protocol. If it's not out of the box, it's through plugins or something. There was an article about a line-based editor or a editor from the 60s being built to support LSP protocol. Hell, even Emacs supports LSP protocol, and it's built in the 60s. And you are able to bake this into the editor itself as long as the editor's APIs are expandable enough to support the protocol itself.
Yeah, but was Eclipse somehow related to the beginnings of this?
As far as I know, no. I haven't ran into any Eclipse talk. Maybe it's wiped from the internet for good, or it's as far as I know, Microsoft has been the forerunner in driving this protocol forward with their adoption of it in Visual Studio Code, and then just being the forerunners in the spec of the protocol, the same way, for example, Google really runs the spec on the web and the W3CG. So yeah, I think that's all for me.